Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Abutewa Sos Ugobela Wemet. And without any further ado, let's look at this question that we have here. Okay, so we have question 4, still on Newton's second law. It says, in the diagram below, a 5 kg mass on a rough horizontal surface is joined to a 3 kg mass by a light inextensible string running over a frictionless pulley. The system is initially at rest, right? So we can see that we are given this diagram here, and just below the diagram, we can see a very important statement. The kinetic friction between the 5 kg mass and the surface is 4.5 Newton. So this is suggesting that the system is no longer at rest. Remember, we can only experience kinetic friction when the system now starts to accelerate, right? So that means the blocks are now moving, and therefore we experience that kinetic friction. Then 4.1 says, draw a free body diagram showing all the horizontal forces. Note, showing all the what? Horizontal forces acting on the 5 kg mass. And as you can see, it's only 2 marks. So we only need to show the horizontal forces. Okay, so this is our object, the 5 kg mass. And then on the right hand side, we can see that we have our tension because these are joined together by that string. And then to the left hand side, opposite the direction of motion, is obviously our kinetic frictional force. So we can say that's Fk, or let's just say that's frictional force, right? Because at this point, we don't know whether we are drawing while it is still stationary or when it's now moving. They did not specify. Then 4.2, calculate the acceleration of the system. So how are we supposed to calculate that? To calculate the acceleration of the system, obviously, this is a system, so we would need to apply our Newton's second law separately on each of these blocks, right? So let's begin. We will say, okay, this one represents the horizontal forces acting on the 5 kg. And then obviously we also need to indicate the free body diagram for this one, because remember I said when calculating the acceleration of the system using the 2 blocks here, always remember to draw the free body diagram for the other one, right? Because you'll also need it for your calculations. So if we are considering that this is already moving, we know that our gravitational force will have to be pulling the 3 kg block down, and then this here will be our tension force, right? So we have Fg and tension. And then look at this. I have deliberately made my Fg to be longer than the tension, because all I'm saying is that if this block is being pulled downward, that means the gravitational force is greater than the tension. So this is being pulled downward as a result of your gravitational force having a greater pulling force than your tension, right? So, okay, now let's indicate for our calculation, we're going to say for the 5 kg mass or the 5 kg block, then this is what we have. F net is equals to ma. Now, if I'm taking the right hand side as the positive direction, that means I have plus here and then minus. But then when it comes to this, remember, I do not have right and left, I have up and down. So the motion here, it's going downward. So that means I take my Fg as a positive and then take my tension as a negative. Remember, the positive direction is always the direction of motion, and the negative direction, it's the opposite direction of motion. So according to our vertical movement here, this is going downward. So that means our Fg is positive since it's going downward, but our tension is negative since it's the opposite direction of motion, right? Then now let's consider this. This will be tension minus the frictional force is equals to m times a. Then let's just substitute. We have tension, but then remember we are given the frictional force or the kinetic frictional force, which is 4.5, right? And then mass, our mass is 5. We don't have the acceleration. That's what we are looking for. But then to calculate, let's make t the subject of the formula. I will have 5a plus 4.5, right? Then let's go ahead and name this equation 1. So, okay, now let's consider for 3 kg block. So I'll say for 3 kg mass, then my equation is F net is equals to MA. But then here I have Fg minus the tension is equals to MA. Now this is Mg minus T is equals to MA. Let me go ahead and substitute. My mass is 3. Gravitational acceleration is 9.8 always. Minus tension, and then here I have 3a, right? So this, when I multiply, it gives me a 29.4, then minus t is equals to 3a. Remember, I just prefer to make t the subject of the formula, so I'll just say 29.4 minus 3a is equals to t. Then I'll call this my equation number 2. Now, since both these equations have t as the subject of the formula, I can just say, let me equate equation 1 and equation 2. So I'm just going to go ahead and take this expression here, 5a plus 4.5, and then I equate it to the expression in number 2. So that's 29.4 minus 3a. Now at this point, everything with the variable a, I will just put it in one side, then 5a plus 3a, then all the constants to one side again, 29.4 minus 4.5. Now this will give me 8a, and then subtracting these ones will give me 24.9. Now I have to divide both sides by 8, so that means my acceleration is now equal to 3.11 meters per second square, right? And that's how you were supposed to calculate the acceleration. So it was only just for about 4 marks. So you might say that they were a bit unfair in terms of the mark allocation. But then again, it is what it is. You were supposed to find the acceleration, whether you feel that the marks that they awarded you there were fitting for this question or not. Then 4.3 says, describe the motion of the 5 kg block when the 3 kg block lands on the floor. Assume that the 5 kg block does not reach the pulley, right? So what will happen here? So we are just assuming that now the 3 kg block will be here. And then now we want to know what will happen to the velocity of the 5 kg block when the 3 kg block is now rested here on the surface. Now, obviously, because we won't have that greater tension force now, because remember, there will no longer be a need for the pulling here, because this is already downward here. So that means what we'll experience from the 5 kg block is that its velocity, so the velocity, so we'll say the velocity of the 5 kg block or of the 5 kg mass will decrease until the block comes to a stop. So when this is now rested here, now we will experience the 5 kg block just going slower and slower up until a point where maybe it stops here. Remember, they said assume that it does not reach the pulley. So it does not reach the pulley because it's no longer experiencing that pulling force there. So this is the 5 kg being at rest at this point. Okay, and that's how you were supposed to tackle the question, guys. Please press the thumbs up button if you've enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please smash that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.